Hello, welcome guys to another video we have today, path with minimum effort. This question has been asked by Cohesity, Google, and Amazon, and I'm sure other companies have asked. Um, it looks like a very good graph question to solve. So the question reads: You're a hiker preparing for an upcoming hike. You are given heights, a 2D array, rows times columns, where height row column represents the height of a cell, row call. Okay, cool. You are situated at the top left, and you hope to travel to the bottom right. Cool. You can move up, down, left, and right, and you can. If so, and you wish to find a route that requires a minimum effort. The root effort is the maximum absolute difference in the height between two consecutive cells of the root. Return the minimum effort required to travel from the top left cell to the bottom left cell. Okay, so the question is essentially saying, right, like you're at the top left cell, you want to go to the bottom left cell, right? Which path are you going to take that has the maximum absolute value, like the minimum maximum absolute value, right? Think about it, right? So the absolute value of the difference between the heights, consecutive heights, right? Which of them has what's the minimum of that? And note that the maximum, the root path is the maximum absolute difference. So, for example, let's use this path. I remove from 1 to 3, right? That is the difference is 2, right? And 3 to 5, difference is 2. 5 to 3, difference is 2. And 3 to 5, difference is 2, right? So this path has a maximum absolute difference of 2. So that is our path with the minimum effort, because the all other paths are not going to yield that. So let's say we start at 1, go to 2, right? The maximum, the absolute difference is 1. However, from 2 to 8, for example, right, the absolute difference is 6. And that is exceeding the one we have for here. So how do you want to solve this problem? Basically, you're going to use a bit of the greedy algorithm, right? So we are going to choose greedy, right? Like which of our paths has the minimum effort? Because if I choose like wherever I start with, if the next element to it has a very low effort, right, that means the absolute difference between them is going to be low, right? So basically, you're going to try and do it greedily with a modification of the Dijkstra's algorithm, basically. So with Dijkstra's algorithm, right, like we have our starting nodes, right, which are single source, and then we have our destination. And every node that we have a visitor, right, we keep it at the infinity. And once we visit a node, we update, so we relax our edge based on that. So what we're going to do is to greedily pick, right? So basically, if we stand here, I'm going to ask myself who has the least effort going forward, right? And then we choose based on those who have the least effort going forward. So that in the end, when we actually reach what's here, right, which is the final place, right, we would have picked the path with the least maximum, so the least absolute difference in height, right, between consecutive heights. So if I pick one height, I'm asking myself which one is the least next that I can pick, right, and so on and so forth. So that will be how we're going to do it really. I don't want to like waste y'all's time. So basically, we want to have m, right, which is height of length. So I want to keep the height and then the length, right? Because with this, we're going to construct our own distance array, right? And what's going to be in our distance array? Well, distance array is going to keep what efforts, right? We're going to keep the efforts, right? The least effort we've had so far, basically in that box, right? So we'll be updating it as we go. And so it's supposed to be least effort, basically, right? And then also I want to keep I think we already have heights, right? I want to keep a Boolean array for the nodes you've already visited, right? So I want to call it visitor, and then it's basically minus. Cool. So basically, we want to fill the distance array with infinity, right? Because the max effort, basically, we're trying to do it with the way Dijkstra's would. So like doing it with the modification of Dijkstra's algorithm, right? So I think height is case less than m and k plus plus. And now I'll say arrays.fill, right? Instance k. I'm going to fill it with integer max value, right? So after doing that, now we want to have a priority queue to which we'll be adding elements. So a priority queue will take an edge, and we're going to define the class edge, right? But basically we'll have the elements in our priority queue sorted according to their edge values, right? So we want the ones with the least edge value. So let's go outside and define the class edge, right? Basically, we need the efforts. I'll be the first element I want to keep, and then the I and then the j, right? So basically, the x and y coordinates, or the I and j coordinates of the elements, or like the coordinates of the cell, right? The row and column it is in. That's the other elements that we'll have in in our class, basically, right? So this.j is equal to j, right? So define our class. Now for priority queue, first we add what our standing position, right? So initially we are starting at what height 0, 0, right? And then we give it 0 and 0, basically. So whatever value that is, and initially for this problem, for example, it would be 1, right? So it would be 1, 0, 0. This is what we are adding first to our priority queue. and then we'll process stuff going forward, right? So basically, actually, let me sort in by the least effort, right? That's how we're going to do that. So we're going to pick, and just before that, I want to have what direction array, right? Because it says we can move on left, right, and I think up and down, right? So what I want to do is I define these variables so that in the end we can use them, right? So as that is done, the direction array is done. Actually, I just want to copy direction array and put it higher so it looks cleaner. Cool. So now we're going to go through our priority queue, right? So once our priority queue is now empty, what we want to do is get the edge, right? So I want to call the edge current. So whichever edge we get first, and then I want to keep the I and then the J coordinates in what's Y and X, sorry, X and Y respectively, right? And after that, I also want the effort, right? So I'll call it current effort, which is what current dot effort. Now, if we've already visited, X, Y, right? Then we continue. We don't want to go back. Like let's say initially we chose 0, and then we look through all the possible directions, and then we've passed 0. We don't want to come back to 0. It's redundant. We are only looking to get to the last element, right, in the grid. So if I previously visited that, then we do not need that. And if we are at the last element in the grid, right, whoever reaches there first, right, that means we have we've really selected and everything is fine. We have the minimum effort. We want to return our current effort at that point, right? That's what we're going to do. We're going to return our current effort. So if not, then what we want to do is have a for loop where we are going to go through each direction. I want to call it dr of directions, right? Typo directions, and then give it an a. A will be x plus dr0, right? Which is the x coordinates, sorry. And then same with b. And now we have our x and y coordinates where we have them in A and B now. So we're going to check if it's inbounds, right? So if it is inbounds, right? So if A is equal to 0, greater or equal to 0, and it's less than m, and B is also the same, greater than equal to 0, and B is also less than n. And what we've not visited, right? We've not visited the node AB. If we haven't, right, then we can do some processing on it, right? Right. So we can do some processing on it. Now the question is, what kind of processing are we going to do? Right now we want to keep a score of what's the effort, right? The effort that we're going to use, here. So basically, the effort is like we're going to ask ourselves, right? Is the current effort between the current effort, right, and the max or absolute value, right? Max or absolute value of whatever we have, right? Like which is what current effort. Sorry, I think the current cell. Sorry, so it should be height AB, right, minus height xy. So the absolute value between now the current and now the new position we are going to, which is what A and B. If it is greater than our current effort, right, then we wanna use that. Actually, I want the min instead. Sorry, not the min. So not the max, but the min, right? Because initially you will have the infinity essentially over there. And I think one other thing that I forgot to do is if we start processing a node, right, which is what we process xy, what we want to do is set it to true, right? Like I've already visited that. That's what I'm saying. So basically we get the current efforts, right? Now if distance, I think called distances. I think it's called distance, right? So distance of AB. Now if that is already less than our effort, sorry, it's greater than our effort, what we want to do then is to update it, right? We want to update it because we are taking the least effort so far, right? So we want to set it to effort, and then now we want to create a new edge, right? So PQ to add a new edge, and basically that edge will have what effort as its first coordinate, and A and B, right? A and B as its next coordinate, and then we're going to add that to our priority queue, right? And just continue the processing from there on. Once everything is done, right, our while loop is done, when we break from our while loop, and I hope we will never reach this side, but basically with Java, we're always being asked for a return value for our int functions and stuff like that. So I need to make sure we return -1 in that case. So I think the logic is sound. Sorry. We can't find the symbol visited, so I'm trying to see the issue. Visited, sorry. Typo the visitor, using visited here. Okay, cool. So once that's fixed, our code is actually running, just filling a few tests. Okay, cool. So what am I missing? It's returning 0 instead of 2. There's no way it's 0 unless we actually not moving. Hold on, let me think. Oh, I see. I think the issue, I think it stems from here, right? It's something we missed. Basically, when we added the edge um, of like this side to um, the priority queue, right? What we had to do also is to set our distances 0, 0, right, to 0, right? Because the max, basically, the max effort we've seen so far is what's supposed to be 0. Because initially, if you start at 1, right, we haven't like had any difference between any like no. So when they set that one to 0, right? So that's something I didn't do, and it seems to pass with the other test cases, but it didn't pass with that one. But isn't it's initially set to 0. However, by me putting it into charge of max, it's going to change. So it wasn't 0. Okay, cool. I think that's what makes sense. So it's distance. Okay, um, even with that, it's not solving the issue. So I think it's more to the bug. Once again, I see. I think actually, this is the issue. So it was initially supposed to be max, and I said min. So basically, we want the minimum effort, right? So that's why we are greedily choosing the elements or the minimum effort, right? The edges that will add with the minimum effort. However, an effort is the maximum absolute value. So absolute difference. So me having a minimum here is why it was failing, right? And it keeps failing more tests actually. I really am missing something now. But basically, this is supposed to be max, right? Oh, also another issue is that it shouldn't be height 0, right? Height 0 is just the height, except it should be 0 initially because the initial edge has 0 effort. As I was pointing out here, the distance 0, 0 is 0 because it hasn't had like any previous element. There's no subtraction, so initially this will be 0 in terms of the distance array. Because in the distances array, right, or the distance array, we are keeping our least effort so far, and the least effort for the first one will be 0. So it's supposed to be 0 here also. Um, so yeah, passes these three cases. Basically, the modifications I made, right? Adding, making sure it's 0, 0 here, adding this initially to the distance array of 0, and also changing here from min to max, right? Because it's a max. The effort is the max, absolutely different. So those are mistakes I made. Let's see. How is going to go? Oh, come on, my internet is bad. Cool. So 77%. I think it's even faster, honestly. Like seeing faster runtime. Yeah, 99%. Very fast code. Most people will probably even doing this. I use Dijkstra's algorithm basically. But basically, it's like a greedy method where we are greedily choosing what's the next node with what's the least effort, right? And basically, we are going to be adding edges or the nodes as like we go through the priority queue. And when we update, basically, we are adding them every time we update the distance array, which initially is having every element set to what infinity, anyways. So there will be new nodes created once our priority queue is done. And hopefully, before it terminates, it hits this condition, right? If we reach the end, while return our current node, and that is guaranteed because we are picking them greedily, right? It should guarantee to be what you know the least effort for at least for that part. So now the question is, what is the runtime? What of n operation here, and n log n operation here, and basically every node is getting touched, right? So at most there'll be n nodes created, right, for each element in the grid, and for each of them we go in 4 directions, right? So basically, it's going to be 4 times n, which is O of n still. So basically, the whole algorithm is an O of n, N log n algorithm, where the priority queue takes the most time. So I hope you guys enjoyed it. You can check the code in the description below. Sorry it took like too long debugging, but basically these kind of stuff is very important. The max and the distance, for example, and also adding what's the 0 effort first. So thank you. Without further ado, and hope I see you guys on the next one. Please like it and subscribe if you can. Thank you.